Hi everyone, in this video we're going to go over chapter 10.8, which are systems of nonlinear equations. So in previous chapters we've done systems of linear equations, but in this time, so those were the methods learned in section 10.1. They could still be used here for nonlinear equations. So we have like our substitution, elimination method, and then we also have our we have our graphical method. So we could still use those methods here. So for example, we're going to find solutions to the system and we're going to use our substitution method. So I have x squared plus y squared equals 100, 3x minus y equals 10. So I'm going to go ahead and solve for y in equation 2. So I have y equals 3x minus 10. So now I can substitute. So I'm going to substitute y into the first equation and then solve for x. So I have x squared plus 3x minus 10 squared equals 100. And I solve for x, so I could distribute and expand the 3x minus 10. So I get x squared plus 9x squared minus 60x plus 100 equals 100. So now I could combine my x squares. I get 10x squared minus 60x, and then I subtract the 100 over, and I get 0. So now I could factor 10x from my equation, and I get 10x times x minus 6 equals 0. And I could use the zero product property. So I get 10x equals 0 and x minus 6 equals 0. So then I get x equals 0 or x equals 6. So I'm going to back substitute these values of x into y equals 3x minus 10 and find y. So for x equals 0, I have y equals 3 times 0 minus 10, which is negative 10. And for x equals 6, I have y equals 3 times 6 minus 10 equals 8. So I have two solutions. So I have 0, negative 10, and 6, 8. And you can substitute those back in to make sure that they satisfy the system. And they do. And here's a graph of what this looks like. So our x squared plus y squared equals 100. That's a circle. And that has radius 10. And then our 3x minus y equals 10. We know that was y equals 3x minus 10. And that's a line. So our solutions to the system are when the line intersects the circle. So that's going to be at 2 points. Okay, so our next method was the elimination method. So I have 3x squared plus 2y equals 26 and 5x squared plus 7y equals 3. So I'm going to eliminate these. So I'm going to go ahead and eliminate the x squareds, and I'm going to do this by multiplying 5 by equation 1 and then negative 3 by equation 2. So I have 15x squared plus 10y equals 130 minus 15x squared minus 21y equals negative 9. And I'm going to go ahead and add. So when I add these, the x squareds cancel out and I get negative 11 equals 121. So my y equals negative 11. So I go ahead and back substitute. So I have 3x squared plus 2 times negative 11 equals 26. And I could plug in the negative 11 into either equation, but I just chose the first one. I get 3x squared equals 48. X squared equals 16. So when I take the square root of that, I get x equals plus or minus square root of 16. So I get x equals negative 4 or x equals 4. So therefore I have two solutions. I have negative 4, negative 11, and 4, negative 11. So that's the place where these two parabolas here intersect. So here's the graph, and these are my 2 points. And it's basically the same y value, different x values. Okay, so our graphical method. So I have x squared minus y equals 2, and 2x minus y equals negative 1. So I go ahead and solve for y. So I get y equals x squared minus 2, and y equals 2x plus 1. So you guys could go ahead and graph this on your graphing calculator or Desmos, but here I have an image of that. And I could see the solutions are going to be the points of intersection. So our solutions are -1, 1, and 3, 7. Okay, I'm going to go ahead and stop the video, and we'll continue the next video with 10.9. So follow me there.